Proving lines parallel. So to begin this unit, we talked about angle pair relationships that exist when any two lines are cut by a transversal. You don't have to have parallel lines. Then we talked about how parallel lines affect those angle pair relationships and whether or not we had congruent or supplementary angles as a result. Now we're going to do the converse of the last lesson. We're going to start with knowing something about the measurement of the angles involved, and we're going to go backwards to prove that the lines are parallel. So, how do I prove lines parallel? Well, we have several ways to do it. We can use the corresponding angles converse. If two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So, for example, as I look over here on the left at my diagram, angles 2 and 6 are corresponding angles. So if angle 2 is congruent to angle 6, then line L is parallel to line M. All right, another way to prove these lines parallel. If two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. This is the alternate interior angles converse. So let's take a look at my example. How about angles 3 and 5? So if angle 3 is congruent to angle 5, then line L is parallel to line M. I hope this, oh good, the smartboard did catch up with me. Okay, a third way to do this. If two lines are cut by a transversal and alternate exterior angles are congruent, what do you think this one's called? The alternate exterior angles converse. So let's see here. How about 1 and 7? If angle 1 is congruent to angle 7, then line L is parallel to line M. And we have one more. If two lines are cut by a transversal and consecutive interior angles are supplementary. So the consecutive interior angles converse. So let me see. Consecutive interior. How about 4 and 5? So if the measure of angle 4 plus the measure of angle 5 equals 180 degrees, then L is parallel to M. You owe me 4 note cards. So let's practice. Is it possible to prove P and Q parallel, and if so, how? Okay, so here's my transversal, which I always like to go over in color to stand out. As I look at these angles, 130 and 50 are consecutive interior. In order for P and Q to be parallel, these two have to add up to 180. So let's see what we've got. So I'm going to say yes, consecutive interior angles converse. Let's look at the next one. Here is my transversal, the line that intersects the other two. Let's see, the marked angles are alternate exterior. Alternate exterior angles have to be congruent. X equals X, that's a true statement. So yes, alternate exterior angles converse. Okay, here's my transversal. The two marked angles are both 70 degrees and they are corresponding angles. Corresponding angles have to be congruent or equal, and this is true. So yes, corresponding angles converse. Alrighty, here's my transversal. Ooh. The 75 and the 115, they don't have a direct relationship to each other. I could use corresponding angles to say this angle is 75, and then these two would form a linear pair and have to equal 180. 190 degrees, so no. Hey, there's no way to make that one work. Let's look at the next one. What's the angle pair relationship here? These two are vertical angles, and vertical angles don't allow me to prove lines are parallel. So this is another no. Let's see, here's my transversal. The two marked angles are corresponding, and they have to be congruent. They're marked as congruent, so I've got, yes, the corresponding angles converse. So as you approach these, ladies and gentlemen, and we have a whole nother page of them, you are asking yourself, what is the angle pair relationship? The name of it. What type of equation is involved? Do the angles have to be equal? Do they have to add up to 180? And then what is the name of that theorem that allows you to prove the lines are parallel if the lines are parallel? Maybe that they're not. So you have 2, 4, 6, 8 that I want you to pause the video and try on your own, please. All right, let's take a look here. In my first example, I had alternate interior angles that were equal in measure and therefore congruent. So that was the alternate interior angles converse. In my second example, going across the top, those are consecutive interior angles, which means they have to be supplementary. But when I added the measurements together, it didn't work. So the answer is no. Second row, that's a linear pair. Linear pairs do not prove lines parallel. So that was a no. Going across to the right, I have corresponding angles that are equal in measure and therefore congruent. So yes. Third row, vertical angles. Vertical angles do not prove lines parallel. So no. Going to the right, alternate exterior angles that are equal in measure and therefore congruent. So yes. The next one took me 2 steps. I didn't talk about a same side exterior angles converse because what I used was a linear pair here on line Q to determine that the angle was 90 degrees and then my corresponding angles converse. And finally, consecutive interior angles, they have to be supplementary. 90 plus 90 is 180. So the consecutive interior angles converse. All right, so we're going to determine which lines, if any, are parallel and state the converse that justifies our answer. Okay, angles 2 and 4. You know I like to bring my transversals clearly into focus. I'm going to make each one of these a different color. Okay, 2 and 4 are both on the yellow transversal, transversal A. 2 and 4 are corresponding. So yes, C would be parallel to D, corresponding angles converse. 5 and 10. 5 and 10 are on the purple transversal, line C. If 5 is congruent to 10, they're alternate interior. Since they're congruent, yes, A is parallel to B, alternate interior, angles converse. Okay, 6 plus 10 equals 180. 6 plus 10 are also on my purple transversal. They are consecutive interior angles, which means they have to add up to 180. That's what I'm told is happening. So that means A is parallel to B. Consecutive interior angles converse. 1 is congruent to 14. 1 and 14 are also on my purple transversal, line C. They are alternate exterior angles. So again, A is parallel to B. Alternate exterior angles converse. Let's see, 14 and 15 add up to 180. 14 and 15 are on the blue transversal. They're consecutive interior angles, which have to add up to 180. So line C is parallel to line D. Consecutive interior angles converse. 11 congruent to 16. 11 and 16 are vertical angles. That does not help us. Nothing. Vertical angles don't prove anything congruent. All right, 4 and 15. 4 and 15 are both on the green transversal. They are alternate exterior angles, so if they're congruent, A is parallel to B. All right. At this point, you should have a good feel for how to do this. I want you to pause the video and try the last 4 on your own. Okay, so these last 4, letter H, angles 10 and 12 are corresponding. So if they're congruent, we do have parallel lines using the corresponding angles converse. Letter I, 9 and 13 are a linear pair. That does not help us, so that's a no. 2 and 7 are alternate interior angles, so if they're congruent, we do have parallel lines. And 6 and 11 have no relationship at all to each other, so that didn't help us in the slightest. Oh, wow, we're making this a lot more complicated. Okay. Let's see. I need another color. How about orange? That'll work. Okay. If 9 is congruent to 22, 9 and 22 are both on the purple transversal. They are alternate exterior angles, which have to be congruent. So Q is parallel to R. Alternate exterior angles converse. 8 plus 13 equals 180. 8 and 13 are both on my orange transversal. 8 and 13 are consecutive interior angles, which have to add up to 180. So P is parallel to Q. Consecutive interior angles converse. All right, at this point, I'm going to say pause this video and try this on your own. These are more challenging because there are more lines involved. Okay, so take a minute and look at this. The one I want to talk about is letter G. Angle 10 congruent to angle 13. When I first looked at that, I said, okay, they're both on my green transversal, line Q. They're consecutive interior, but wait, consecutive interior angles have to add up to 180. They're not congruent. So that was the only none on this entire list. Letter J is worth noting also because S and T don't look parallel, but if that's the given information, they are parallel. All right, I believe that's it for this lesson. I want you to write a summary about how this lesson relates back to the last one and what's the approach to determining whether or not lines are parallel.